Hi all, my name is Becca, and if you haven't seen me before or met me before, you can find me at sciencelessonsthatrock.com. I'm also on Instagram and Facebook at sciencelessons.rock. I am currently a high school biology teacher, and I have a deep love of earth science as well. So today I'm going to bring you a quick demo that you can use for biology and a lab for earth science. Okay, for this first quick demo, this goes with your biochemistry or macromolecules unit. I always have lots of teachers asking me, how do we make macromolecules more fun? It's not the most engaging topic, but it's important that students have a basic understanding of what they are and how they work before you dive into cells. So I'm going to show you a quick demo for lipids. When we introduce lipids, we want them to understand it because we're going to talk a lot about cell membranes and how things travel in and out of the cell. One thing you might teach students is that lipids are great insulators because lipids are fats. So animals that hibernate are going to fatten up before the winter, before they hibernate, because it's a great insulator. It's going to keep them warm. So to show them a quick demo for this, all you're going to need is a bucket of ice water, 2 baggies, and some shortening or some Crisco. Okay, the first thing you're going to do is grab one of your bags and you're going to fill it up with Crisco. So I'm just going to spoon a bunch in here. Okay, and I'm going to take my second bag and I'm going to stick it inside and try and flatten out the Crisco, so that way I have a place where students can stick their hand in that's nice and clean, and then it'll be surrounded by a layer of Crisco. Okay, so I have this double layered bag. Students will be able to stick their hand in the inside layer and hopefully not get their hands all goopy and gross. So what we're going to do is we're going to have students, we live in a time of COVID right now, so wash their hands first or put on some hand sanitizer, call up a student that wants to volunteer and stick their hand in, actually take that back. Sorry, first they're going to stick their hand in the ice water and you're going to time them. How long can they keep their hand in the ice water without them freezing their hand off? Okay, so I have my bag. You could even put taper on the top or even fold one layer over just so we don't have Crisco coming out the sides onto their hands. And then start a timer, have your students stick their hand in the ice water. It's going to be really cold. How long can they keep it in? Obviously you don't want them to get frostbite, so after like 10-15 seconds probably they're going to be freezing. So take their hand out, dry it off, and then talk about Crisco is a fat, Crisco is a lipid. Lipids are great insulators, so let's see what happens if they stick their hand that's covered in the Crisco into the baggie. Now time how long they can keep their hand in. Right now I feel nothing. I don't even feel any cool temperature at all, so it'll take a while. So that's just a great quick demo that you can do to show students how lipids are great insulators. For the lab portion of today's presentation, I want to show you how you can do an activity to have students map the ocean floor. So we talked to students about how could we know what the bottom of the ocean floor looks like when I'm not physically traveling down there. Yes, we can send down submersibles, but the water pressure is so strong once you get down deep that it's not always practical. So what's a quicker, more efficient way to do that? So we can use sonar. You could easily just pull up a YouTube video and show students how sonar works with sound waves to map the ocean floor. Another really cool resource while I'm thinking about it, there's a website called nautiluslive.org where they, not always you have to catch them at the right time, but they have a live stream of a submersible that's down at the ocean floor and they're collecting data. So even if you're not catching them live, a lot of times they have videos from previous trips that are up there that you can show students. Okay, so what you're gonna need for this activity is some shoe boxes. You're gonna need 1 per lab group. So if you typically do like 8 groups in your class, you'll need 8 boxes. You can collect them over time. You can have students bring them in. You could use like Amazon boxes, but I like using shoe boxes a lot better. You can download this lab worksheet in the manual that you get from Demo Days. There's 2 versions included. There's a middle school version, which I'm going to show you first, and then there's a high school version that's a little bit more complex. So what you're going to do first is, before you even get to class, so I would recommend doing this at home, is you're going to set up your boxes. For the middle school version, there's going to be just a slit down the top, so students are just going to take 1 row of data and create a 2-dimensional map of the ocean floor. For the high school version, there's going to be a grid, I'll show you in a second, and they'll end up with a 3-dimensional map. On the inside, you're going to, I just grabbed some recycled materials to build my model of the ocean floor. So I just have some cardboard, this is a toilet paper or paper towel roll. You could use the top of a water bottle, or this is just a portion cup, and I'll show you what to do with them in just a second. Okay, so here's my shoebox. To start off, I'm gonna have a continental shelf and a continental slope. So I have a piece of cardboard here and a hot glue gun. I'm gonna hot glue this piece of cardboard here. So it's a continental shelf and continental slope. Okay, so there's what that looks like so far. You can have every box be different. You can have them all be the same. It's up to you. You can take the top of a water bottle and cut it off, or this is just a portion cup, and glue that in. That could represent a seamount or volcanic island coming up. You could make a mid-ocean ridge. So I took the paper towel roll, I opened it, and I'm gonna fold it so it almost creates like the McDonald's arches, kind of. And I'll glue that in so we can have a mid-ocean ridge. So I'll do that in this one. Okay, so that's what this one looks like from the inside. You may be thinking, Becca, ain't nobody got time for that. I realize that it takes some time to set up, but you can use these year after year, like for a long time. Next thing I'm going to do is I'm going to cut a slit right down the middle. This is if you're doing the middle school version. Okay, and then with a metric ruler, I'm going to put hash marks every 2 centimeters. Okay, and then lastly, I'm going to label them alphabetically. So A, B, C, D, etc. Okay, so every group is going to need a wooden skewer. You can find these at the grocery store. Sometimes over the summer you can find them at the dollar store if you're lucky to save money. So essentially what students are going to do is they're going to be sticking the the wooden skewer in until it hits something and stops. They will put their fingers there to pinch, pull it out, and I know it went in this deep, and I lost my ruler. They'll hold it up to the metric ruler, measure it, and then record it on their data table here. A couple troubleshooting tips. First, if you're worried about students opening the boxes, put a piece of painter's tape around the side. So that way at the end, if you do want to let them look inside, it's easy to take off, but they hopefully won't be peeking. Also, if you're worried about students poking each other, then you could always cut off the pointy tip. Again, usually as long as you talk to students, this is not a weapon, it's lab equipment, then they should be fine. So they're gonna do that ABC all the way across the top of the box, and then they will be recording on their data table. And then lastly, they'll graph it on here and connect the dots to create this 2D profile, and there's some questions that go with it. All right, the high school version is going to take you a little bit more time to set up as far as the lid goes. So this one I already have set up. So I have my continental shelf, continental slope, any flat areas will be abyssal plains, and then I have my C-mount. So when you are doing the lid, instead of a slit down the middle, this time we're going to do a grid. So I put little dots with a Sharpie every 2 centimeters. And then I have a thumbtack, and I'm gonna go through and I'm gonna poke holes for students. And then I have labeled each of the columns numerically and then each of the rows alphabetically. So when they go to collect their data, they'll start at like A1 and then A2, A3, and they'll work their way all across the lid. So this one's gonna take students more time to collect their data. So depending on your class period length, and how efficient your students are at measuring, you might have to do 2 class periods for this one. Okay, so you get the idea. I have my gridded lid. They're gonna do the same thing. So take their skewer, stick it in until it stops, pull it out, record. This time the data table looks a little bit different, so they're gonna have lots of measurements. And then they're going to create their 3D model from here. So I'll show you how they can do that. Okay, once students have their data table filled out, I just did some hypothetical data so you could get the idea. They're going to transfer their data onto these charts. There's 6 of them, A through F, just like you have from the data table. So they're gonna graph all their data from A, then they're gonna graph all their data from row B, C, D, E, F, etc. Okay, the last thing they're going to do is they're going to cut out the grid, and any space above their points, I'm gonna cut off. So you might wanna do one of them up front to show students so they don't get confused. Okay, so that one looks like that. Also, once they cut it out, I would recommend they put the letter on the back. So this one was A, just so they don't get confused. So I'm gonna go ahead and cut out the others and then show you how to assemble it. Okay, so at the bottom of each one, it says fold and glue. So where are they gonna glue it? They will only have to do 1 per group is what I do, because I don't want students to take too much class time cutting and gluing, so they can split it up. So if you have lab groups of 3 students, they can each do 2. So at the bottom of their lab worksheet, it says bathymetric model. And so they will fold the bottom tab and then glue the A1 and the A row, B, etc. So let me do that real quick and then I'll show you. So when students are done assembling, it will look something like this. Well, it'll vary based on how you built your box. But they will have a three-dimensional model. They can see that the continental shelf and slope was the same all the way across the width of the box, but I had that one C-mount in the center. Again, I only have one turned in per group to save time and paper. Thanks for joining today. I hope that you found that demo and lab activity useful. Again, you can always find me at Science Lessons That Rock. Send me a DM if you have any questions and I'll be sure to respond. Thanks.